I believe that you have done a lot of past year questions, did you? No worries if you have not done the past year question yet, because today we are going to do full discussion on the past year paper. This is October, November 2020, paper 1-1. Yeah, during the discussion, if you think of a question to ask, feel free to do so. Yeah, so these are all the formula that will be given, and mostly are A2, not AS. So too bad, right? A bit bad. And they give you a resistor in series. I don't know why, because I believe that you have already memorized that. So let us start with the first question itself. Which quantity is a physical quantity? Now, do you still remember what is physical quantity? Physical quantity is the quantity that can be measured or can be calculated by measured quantity. So physical quantity must contain magnitude as well as the units. So which one is a physical quantity to you? Adam say A. Jamie, what about you?
D.
Sorry, A.
D.
D. Yeah? Okay, let us look at it. So atomic number. So when you say atomic number, what is atomic number? Yeah, atomic number is actually, where is it? Okay, I think this one. So if I give you helium, 42He, can you tell me which is the atomic number of helium? Yeah, which is the atomic number of helium? Is it 2 or is it 4? Hey, is that okay? Atomic number is actually the proton number. It is just represents the number of protons in a nucleus. Yeah, so it is not physical quantity because it cannot be measured, it cannot be calculated, it exists, yeah, inside the nucleus. So therefore A cannot be the answer. Yeah, Adam. Efficiency. Yeah, efficiency is how the output voltage or the output power of something, yeah, is related to the input power that you put in. So it cannot be measured because it depends. Yeah, it depends on the input. Yeah, it depends on the energy loss as well. So it is not a physical quantity. Strain is the comparison between the extension and original length. It is the comparison. It is not the calculation. It is just a ratio compare between the extension and the original length. Yeah, Jamie? So D cannot be the answer. So therefore the answer is C, number of density of charges. Yeah, density is mass over volume. So you can do your calculation. Can you see that? Yeah,
Yep.
density of charge carriers. Okay, so you have a unit for number of densities. Yeah,
Means can you
okay.
explain why D cannot?
Sorry.
Can you explain again why D cannot?
Oh, D is just a comparison between, yeah, how long, or yeah, I say extension. Yeah, extension means how long an object is being stretched compared to the original length. You get it? Because strain is extension over original length. It is a comparison, yeah, between the extension, how long the object has been stretched. That is strained.
Oh, okay.
Yeah, so number of density can be calculated because density is mass over volume. You need to get the mass of the charge carrier and you need to get the volume of the wire, so you can calculate the number of density. Yeah, is that okay? So therefore the answer is C. Okay, the most appropriate answer should be C. Yeah, number 2, which time interval is the shortest? So this is about prefixes. Have you memorized your prefixes here? Yeah, Adam said B. What about Jamie? Yeah, I am also doing this, yeah, at the same time. Okay, so we try to do as many questions as possible. Yeah, try to speed up our speed as fast as possible. So this is -3, yeah, milli. And then this is 50, this is nano. I put it in terms of prefixes first. This is 500,000 pico, nano, pico, -12. This is 0.5, mu is -6. So I cannot compare like that because the numbers are different. So therefore I have to put it in the standard form. So the first one, the standard form will be, actually you can use the help of the calculator, yeah? 5 times 10 to the power -5, b 5 times 10 to the power -8, C 5 times 10 to the power -7, and D 5 times 10 to the power -7. Yeah, use your calculator. So you can see that the shortest one is 10 to the power -8. So therefore the answer is B, correct. Yeah? Can I clear that? Okay, yeah? Okay. So what about this? Number 3, P and R are coplanar vector. Coplanar vectors are the vectors that acting at the same point. Yeah, at the same starting point here. If X is equal to P minus R, which diagram best represents vector X? Oh, Adam, you have the paper with you, is it? I better shrink it a bit. Yeah? Have you done this, is it, Adam?
A.
Yeah, I've done paper 1.
Okay, you have done paper 1, but not paper 2, is it? Okay, never mind.
Yes.
Okay, yes. The answer, if everybody give the same answer, then I will not explain, yeah? So that's A. Okay, good. If you don't understand and you are just lucky to get A, let me know if you need my explanation. Yeah? Or else I'll just skip the explanation part. Number 4. A student uses the cathode ray oscilloscope CRO to measure the period of a signal. She sets the time base of CRO to 5 millisecond per cm and observes the trace illustrated below. The trace has a length of 10 cm. So what is the period of the signal? So Adam, do you mind to show me your calculation as well? Because you get the answer. So definitely I want to see your calculation or your method of doing this.
I just key every value into my calculator. I didn't write anything down.
Oh, okay. Never mind. Okay, we'll see later.
Same.
Okay. Same, yeah? Do you need my explanation or do you need my calculation here? No need, right?
Mm,
If don't need, then I will skip, yeah? Okay, good. The answer is donkey. Number 5. The diameter of a spherical golf ball is measured with calipers and found to be 4.11 plus minus 0.01 cm. Volume of a sphere is V equals to 1 over 6 pi d cube, where d is the diameter of the sphere. What is the volume of the golf ball? Adam got the answer. Jamie got the answer. Adam, do you have a method of doing that? Method? Or you just get the answer when you key into your calculator, that's all, is it? If you have a method, feel free to write it down because I want to see how you get the answer, whether you are lucky or you really get the answer. Jamie, if you get the answer, do also let me know, yeah? This part, this is chapter 2, yeah? It is error calculation. Absolute uncertainty, fractional uncertainty, and the percentage uncertainty are very, very important. Make sure that you know, at least you know how to do it, because this type of question will be mostly coming up in paper 1. And paper 2, I don't guarantee, but will be coming up, quite popular.
Miss, I don't get it.
Do you manage to get the answer? No, no. Okay, never mind. I'll do it. Yeah. So the diameter of a sphere is measured in a diameter. This is d. Yeah. The volume is given blah 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 blah. What is the volume of the golf ball? Volume of the golf ball. Um. Oh, okay. I find the volume first, Adam. So I find 1/6 pi. Okay, because all is in cm cube, so I don't even bother. Yeah. So I'll just put 4.11 cubit, and I get 36.352 cm cube. It doesn't matter how many significant figures I want to put in because that is not the final answer. It's just intermediate answer. So, and then to find the absolute uncertainty of the volume, I look at the equation of the volume first. Equation of the volume is, yeah, full of multiplication and the power factor. So if you are dealing with multiplication and power factor, instead of getting the absolute uncertainty, you need to get your fractional uncertainty first. So it has to be delta V over V. 1/6 is just a number, you don't have uncertainty. Pi is a number, you don't have uncertainty. This is d cubed. So therefore, power you just times here, delta d over d. So therefore, delta v, to find delta v, which is absolute uncertainty of v, the value of v I have calculated just now, 352, is equal to 3 delta d. Here, 0.01 over 4.11. Then, yeah, cross multiply, I get my delta V as, yeah, put it in one significant figure only. Cannot be more than one, so it is plus minus 0.3. So therefore, V, one decimal point, yeah, follow the valued reading of V must follow the decimal points of the absolute uncertainty of your V. So therefore it is 36.4. So the answer should be donkey. Yeah, Adam? Yeah.
Miss, I change the D to meter.
Sorry?
I change the
Oh, you
D
change
to
it to
meter.
meter, is it?
So I get like
Oh,
10
oh,
out of
okay. Oh, you didn't see the unit lah, is it? But it's normal lah. Whenever we see cm, we normally change it to meter, standard unit. But in paper one, beware lah. Because yeah, when you see the unit there, beware. Yeah, it could be in meter, it could be in cm cube. But so lucky that this one they didn't want us to change to cm cube. Yeah, Jamie. But in paper two, you want to change to meter cube. It doesn't matter, because normally they won't give you the unit. You have to write down the unit. Yeah. Can I clear that? Can ya? Okay. Now the next one is, okay, number 6. A student cycles uphill from home to a shop, taking 10 minutes. The student then spends 5 minutes to the shop, in the shop, before cycling home downhill at twice the initial speed. So which graph could show the variation of with time of distance traveled by the cyclist?
D. D.
The answer is D. What about Adam choose D as well, is it? Why the answer cannot be B? Yeah?
If it's displacement, then okay lah.
Yes, exactly. You know, I make this mistake. I just want to tell you that I make the mistake. I choose B instead. Then I was like looking, why the answer is D, not B? Because you go back to your house. Then I saw, oh, that's distance. Distance is a scalar quantity. So therefore, distance will only increase unless you're talking about displacement. Yes, the answer is D. Okay, correct. Congratulations. And okay, what about number 7 here? Two cars, X and Y, are traveling along the same straight road. Car X is traveling at a constant speed of 6 meters per second. Car Y has a constant acceleration of 0.5 meter per second square at the instant shown. Yeah, show me the calculation, please. Adam, are you taking further math? Are you taking further math?
Yes.
Okay, therefore, okay, I want to see your calculation, please. How do you get B? Jamie, I want to see your calculation as well. Yeah. Okay. Okay, never mind. Okay. Sy is equal to, okay, you are doing it for y. 4 times 20 plus, okay, 180 d plus, okay, wow, that is very quick. You don't even, yeah, do your calculation for car X. Yeah, you didn't do any calculation for car X, right? Okay, my calculation, yeah, the other day I showed Jamie, right? Okay, so let us look at Adam's calculation first. 4 times 20, 4 times, yeah, 4 times 20 plus, hold on, 20 square, is it? Why 20? Oh, because of time. Okay, hold on. 20 square plus 0 0.5, 180, right?
Maybe I didn't calculate
Yeah, how do you
time
get this
X, but
120,
let me
yeah?
write it down.
Yeah, how do you get that
Yeah,
120? I
I
think I
think
know.
that is the
Yeah,
distance
distance.
of car X.
Yeah, Sx, yeah, is equal to 6 times t. So 6 times 20, so it's 120 second. So, okay, because car X is in front of car Y. So that means the distance of car X, a further distance of car X, plus the distance traveled by the car X at that time is equal to the total distance that need to be traveled by car Y in order for them to meet at the same level, right? So therefore it is 60 meter. Jamie can understand, Jamie? Or you want me to explain? Yeah. So Jamie, when you look at the working of Adam's working, do you manage to understand, or you want me to re-explain this? Ah.
Uh, I actually use your method lah, but
My method is similar to Adam. It's just that I write more words. Yeah. So in order for the car Y to be at the same level with car X, the distance must be the same. Yeah, they have to meet at one point. You get what I'm trying to say? Distance X must be equal to the distance Y. Yeah, Jamie. So Adam was calculating for the distance of car Y first. Acceleration need to be added lah because car Y accelerates. And distance of car X here because car X travel with a constant velocity. So distance is just speed times time, which is 120 second. So Adam say that okay, distance of car X must be equal to distance of car Y after that. Car Y. So car X is given as 120. Yeah, but car X is in front of car Y, so you just add in front a certain d distance. Yeah, is equal to the distance of the car Y that need to be traveled. Yeah, so therefore d is 180 minus 120, which is 60 meter. Very good. Jamie, is that okay or confusing?
okay.
Yeah, okay, is that okay? If you don't understand, then you ask me later. Yeah, okay. Okay, then number 8. The graph shows how quantity P varies with quantity Q for an object falling in air, yeah, in air for a long time. Another keyword is falling for a long time. Yeah, so in a uniform gravitational field, what could be the identities of P and Q? Uh, Hello? Yeah, I lost. I think I disconnected. Is it? Yeah.
Yeah.
Okay. Sorry. Yeah. Check. Yeah, I make sure that okay. Yeah, what is okay, give me a reason why. Okay, um falling, yeah, in air, falling in air. Yeah, let me explain. Yeah, when you fall in air, force of air resistance and acceleration cannot be together because when the acceleration increase, Yeah, when the force of air resistance increases, the acceleration must decrease. So therefore, A cannot be the answer. What about B? Kinetic energy is P, Ke, increases with time. But when you fall so long in air, doesn't terminal velocity is reached? If the terminal velocity is reached, how the kinetic energy is going to increase, right? So therefore, it is not possible as well. And D, work done against air resistance is increasing, so your speed is increasing. But when you do work done against the air resistance, yeah, your speed will be constant. When you fall at terminal velocity, it would not be increasing. So therefore, it's not true. But yeah, potential energy. Yeah, let's say this potential energy is based from the point where you start to fall. So therefore, the distance from the point where you start to fall is increasing. Yeah, with the height. So when the height increases, the potential energy is also increasing based on the falling point, not from the ground. Yeah, because you are closer to the ground. So therefore, when the height increases, the potential energy is also increasing. So therefore, yes, the answer is C. Okay. If you have any question to stop me, yeah. If you don't, yeah, then I will just, yeah, move on with the next question here. A rock, a rock. Okay, explanation, Adam, why you choose B. Jamie, I will read this for you. A rock R of mass 1 times 10 to the power of 27 kg has a large distance from a star S and is traveling at a speed of 1 times 10 to the power of 4 meter per second. The star has mass 1 times 10 to the power of 30 kg. The rock travels around the star on the path shown so that it reverses the direction of motion, and when finally gain again a large distance from the star, has the same speed as initially. Which statement is correct? Hmm. Yeah, he's going to prove that. Yeah, which statement is correct? The change in momentum of S is in the direction of arrow X. Is it? The change. Is it the momentum of X or the change in momentum of X that has to be in the direction of, yeah, arrow X? Okay, this is mass. Okay, this is 10 to the power of 31, right? Am I right? And then must be equal to, okay, he is finding, okay, good. Okay, so V is equal to, yeah, 10 to the power of 31 divide. So, okay, it is a, so V is 10, yeah, meter per second. So the change in velocity, yeah, change in velocity in S is approximately, how do you get approximately 20 meter per second? Mm, mm. A rock R, mass from a star. Traveling, the star has a mass, the rock travel around the star. Yeah, the rock travel, these are traveling around the star of the path shown so that it reverses its direction of motion and then finally gain a large distance from the star. So the rock travel around the star on the path shown so that it reverses its direction of motion and then reverses. Okay, when you reverse the direction, yeah, you reverse the direction, actually, okay, the change in velocity, yeah, or the change in momentum has to be mv minus mu. M will be the same, but yeah, because initially you move in this direction and after that when you move in this direction it is a negative direction, right? You give to your velocity. Let's say this is 10 moving here, or this is 10, final is 10. Yeah, initial is also 10, but one will be negative, the other one will be positive. So let's say give this negative. So mv, let's say this is mv, so m times 10 minus m negative 10. Can you see negative and negative becomes positive? So m 20. So the speed, the change in speed is without the m, so it is roughly 20 meter per second. So the change in momentum of s is in the direction of arrow. Change in momentum cannot be in the arrow of x, because arrow of x, that is initial momentum. Initial is not the change, it's the initial momentum.
It's hard to get to 10.
Sorry, how to get 10? Yeah, okay. So the momentum of r is equal to the momentum of s. You get it? Because r is moving towards s. So the change in momentum of r is equal to the change in momentum of s. Yeah, because the rock is circulating the star and then we reverse the direction around the star. Yeah, so therefore, yeah, we get mv here is equal to 1 times 10 to the power of 4 rock, yeah, is equal to star. Same speed, yeah. So 10 to the power of 4 times 1 times 10 to the power of negative 27 equals star. Star, you only have the mass of star, so we need to find the velocity of the star as well. 30 times v, so v is 10 meter per second. Is that okay, Jamie?
Yeah, okay, miss.
Okay, and then see, the magnitude of the change of momentum is 10 to the power of 3 times greater than the magnitude of change of momentum of s, so it is not. Can you see that? The magnitude is not 10 to the power of 3 greater. The momentum of r does not change. That's not true. Yeah, because r is moving. Yeah, can you see direction changes? So momentum must change. So therefore the answer is B, correct. And the next one, the diagram shows the masses and velocities of two trolleys that are about to collide. Yeah, after the impact, they move off together. What is the kinetic energy lost in the collision? Yeah, give me the solution, please.
Miss, I don't know why I got -6.
Okay, never mind, never mind. I'm going to, yeah. You got -6 is because you lost. That's the kinetic energy that you lost. Yeah, Adam, negative represent the loss in the kinetic energy. So it is true. Ah, Jamie, you managed to get the answer. Adam got the answer, -6. Okay. I noticed that one of the questions in this paper is actually from question number 15. It is actually extracted from 2004. I don't know whether it's May, June, or October, November. Yeah, paper, exactly the same question. So I did not do the solution because I memorized the answer, so I know the answer. Yeah, okay. So Jamie managed to get the answer here. Hmm. Because they move together, so therefore I would say that this collision is inelastic, yeah, collision. So I will have m1 u1 plus m2 u2 is equal to m1 plus m2 times v. I need to find the v first because I don't have the v here. So because I need to find the kinetic energy after the collision, then only I can compare how much kinetic energy has already been lost. Yeah. So m1, because both trolley are moving in the same direction, so therefore m1 is 2 times 4 plus m2 is 4 times 1, like what Adam has done. So and then total mass, because they move together, so 4 plus 2, that's 6v, gives you 6v. So therefore v is 2 meter per second. And okay, the loss in kinetic energy, you have to compare initial kinetic energy and final kinetic energy, EK final. So initial kinetic energy is the kinetic energy of trolley 1 and kinetic energy of the trolley 2. You just add up. So half, yeah, 2 times 4 square plus half 4 times 1 square. Yeah, final kinetic energy, because the two trolley are moving together, so the mass will be the mass of the two trolley, 4 plus 2, that's 6. Yeah, and then the final speed, yeah, between the two trolley when they move together is 2, so 2 square. So you take the final one minus the initial one, just like what Adam has done. So you add out first. Yeah, here I think you get 18 here, Joe. Here you get 12 joules here. Yeah, so therefore EK final minus EK initial, it is 12 minus 18. So therefore you get negative 6 joule. Don't worry about this negative because you are supposed to find the loss. Loss supposed to be negative. Is that okay? Jamie, okay, yeah? If you want to copy, let me know lah, yeah? Okay, can I clear that?
Yes.
Number 11. A particle is situated at rest between two metal plates X and Y. A potential difference PD is then applied across the plate to produce electric field shown. The particle moves toward plate X when the PD is applied. What could be the particle? First of all, determine which is the positive plate and which is the negative plate. You need to tell me, you need to know. Yeah? So yes, whatever Adam has wrote here, yes, this is positive plate, this is negative plate. Why? Because electric field will always flow from the positive plate to the negative plate.
B.
Yeah? So then they say that, okay, the particle move towards plate X. Move towards the positive plate. Plate X is positive. So what particle that could be attracted to the positive plate? None other than electrons. Therefore, the answer is electron. Yeah, neutron is free of charge. Alpha particle is positively charged. Proton is positively charged. Yeah, so therefore they move to plate Y except neutron. Neutral. Yeah, so therefore the answer is B. Correct. And then number 12. Oh, seems to be very complicated here. Yeah. Two people push a vertical gate to open it. The forces exerted by the people on the gate are shown. One person is distance d1 from the gate's hinge and pushes with horizontal force F1 at an angle theta 1 to the other gate. The other person is at distance d2 from the hinge and pushes the horizontal force F2 at an angle theta 2 to the gate. So what is the total moment about the hinge due to the forces F1 and F2?
B.
You get B, right? So I don't have to explain, right? Okay, never mind. Okay, good, good, good. B is the answer. And number 13 here. The ball is rolling down a slope at a constant speed, constant speed. The three forces acting on the ball are the weight, the contact force, normal to the slope, and friction. The diagram could represent these three forces. Yeah, Adam, can you tell me what is the difference between B and D, and why do you choose D but not B?
Is it because it say constant speed?
Okay, when you say constant speed, can you see, Jamie, what is the difference between B and D? Arrow same, everything same.
D, all the sides are same,
Ah,
but B, the two sides are longer.
So which one is the, yeah. So why do you choose D but not B? Yeah. So Adam say because it is normal.
Because constant speed, no resultant force.
No resultant force. Yeah, can you see this one also no resultant force? These three. Yeah,
Oh, then I don't
zero.
know.
This one A and C cannot lah because they have resultant force. So Adam say it is because that this one is supposed to be normal is between the two forces, yeah, reaction. So it seems to be this one theta is larger, this one theta is smaller. Yeah, so when you draw your weight is down here, right? This is your weight. And then the other force is in this direction. Yeah, so therefore, okay, when your weight is here, it seems like, okay, when your weight is down here, it seems like you need to go up a bit lah. So more logical. You know, some of the students circle B because they say that there's no difference. But actually, the difference is that this angle here is smaller. So when you draw it, yeah, it is better using the scale diagram lah if you have, yeah, confused between B and D. So this one angle is larger. Normal angle is like this, larger. So therefore, yeah, the correct answer is donkey, true. Yeah. And the next one is number 14 here. Okay, I'm measuring it a bit. Yeah, one end of a U-shape tube. This is manometer, yeah, is attached to gas tap, and its other end is to the atmosphere. It contains water of density 1000 kilogram per meter cube, and the height of both sides of the water column are shown. Atmospheric pressure is 101 kilopascal. What is the pressure of the gas? Yeah.
Yeah, D.
D, yeah? Okay. Adam, you get D as well. Do you need me to explain? No need, alright? Okay, if you get D, okay, good. What about number 15? This is the one that I talk about. I didn't do any calculation because I know the answer. So, but I want to see how you do the calculation. uh, yeah, how do you get the answer? Yeah, Adam, if you don't mind to show me your working. Jamie, if you get the answer, let me know, yeah? Okay. Jamie managed to get the answer. I am using the principle of conservation of energy, yeah? So a trolley runs from P to Q along a track. At Q, this is potential energy, yeah? So potential energy of Q is 50 kilojoule less than potential energy at P. So it is equal to, potential energy of Q is equal to potential energy of P minus 50, yeah? Kilojoule, I don't bother lah. Yeah. Is that okay? So at P, kinetic energy, Ke of P is equal to 5 kilojoule. Between P and Q, yeah, between P and Q, work done against friction is 10 kilojoule. What is the kinetic energy of Q? So using the principle of conservation of energy, initial energy is equal to final energy. So my initial energy is the potential energy, because at P is very obvious. Yeah, P has potential energy. P plus kinetic energy of P minus the work done against friction is equal to, yeah, PE of Q plus KE of Q. So PE of P, I'll just put PE of P. KE of P is 5, I just put 5. Work done again, friction minus 10 is equal to PE of Q. PE of Q is PE of P minus 50, yeah, plus KE of Q. So PE of P you just cancel. So therefore you have negative 5 here is equal to negative 50 plus KE of Q. So therefore shift this negative 50 to the other side. So it is positive 50 minus 5. So therefore you get 45 kilojoule is equal to KE of Q. Just like that. So therefore the answer is boy. Yeah? Okay. Oh, if you want to copy Jamie, Adam, let me know lah, yeah? Okay. Um, okay, number 16. A hydroelectric power station uses the gravitational potential energy of water to generate electrical energy. So in a particular power station, the mass of the water flowing per unit time is 1.5 times 10 to the power 5 kilogram per second. The water falls through a vertical height of 120 meter. Electrical power generated is 100 megawatt. What is the efficiency of the power station? Okay, Adam got the answer. What about Jamie?
Same.
So I don't have to do, yeah? The solution, I don't have to write down. Good job. Yeah. So what about number 17? Which amount of energy is not equal to 2400? Prove it. Okay. Jamie?
Yeah, it's A.
It's A, right? So the first one is mgh only lah. So you just put in 60 times 40 times 9.81. Yeah, is equal to, I think 20 I get 23544 joule. And then the second one, energy transfer, yeah, by a power. So energy is power times time. Then you will get 2400. Third one, kinetic energy is half mv square. You also get the same answer, 2400. Work done by the gas expanding, so P delta V, that's the work done. So then you get 2400 as well. Yeah, these are the formula that you start in to get 2400. Good. What about number 18 then? A train of mass 300,000 kilogram is accelerating at 0.8 meter per second square. At one instant, the speed of the train is 5 meter per second and the resistive force to its motion is 15 kilonewton. So what is the rate of increase? Rate of energy, yeah, is power. So they want you to find power. Okay. Adam got how do he get the answer? Yeah, wait, I'm looking at my answer as well. Adam got 1.3, is it? Half m 5.75. Adam, do you mind to tell me how do you get 5.75? Yeah, half mv, the v, yeah. How do you get the v? And how do you get 4.95 square as well? Jamie? Well, yeah, I'm doing 300,000 equal to Adam, do you mind to tell me how do you get 5.75 square
I have no idea.
and 4.95 square? I just want to see how Adam did it. Rate, that means per time, you see. But is the time given here? Okay. Why do you take 300,000 times the speed, yeah? mv, is it? mv is momentum, Adam. And then this is a force. Momentum and force are two different things. Beware. You just need to find the energy then per, okay, yeah. Yeah, Adam. I am using this method lah, yeah. So power is equal to energy over time, right? Or I just put work done over time lah. Adam, you can keep on doing lah, yeah. So it's just that when you take this one times this one, yeah, mass times speed is momentum, is not force. So you cannot, unless you take your mass times acceleration, that's force lah. Yeah. So I do power is equal to work done. Work is Fs, yeah, over T. And they say that, okay, P is equal to S over T, that's V lah. But this F has to be a net force, yeah. So therefore, yeah, the rate of increase in kinetic energy is actually the power lah. Net force, I just take the force to accelerate the train minus the resistive force. So F equals to ma, yeah, this one. So 300,000, yeah, times 0.8 minus, okay, to get your net force, thousand times with the speed 5. So therefore you get about 1.13 times 10 to the power of 6. So 1.2 lah, megawatt. So the answer is B. Jamie, is that fine with you? Or you have question to ask?
Yes, I get 1125,000.
1125, right?
Yeah.
Or
Means
one?
if you calculate
1125 1125 000 1 2 3 4 5 6, correct lah. 1.13 ma times 10 to the power of 6. So when you round it off to the nearest, yeah, whole value will be 1.2 megawatt.
Okay.
Yeah, okay, good. Adam, okay, yeah, okay. Number 19, a wire of circular cross section obeys Hooke's law, yeah, used to suspend a basket as shown. Young modulus given, weight is given, strain is given. What is the radius? Okay, Adam got the answer. What about Jamie? Yeah. Formula of Young modulus is not being given, yeah, so I use Young modulus. A Y represents Young modulus. It is stress over strain. Stress over strain, you know, stress is force over area, strain is extension over original length. So therefore F over A divide X over L naught. So therefore F over A, invert it, yeah, L naught X. Yeah, that is my Young modulus. So I sub in whatever is given, like Adam did, 2.5 times 10 to the power 11. I'm supposed to find the radius, so 34 Newton. The strain of the wire, this is stress over strain. Yeah, stress over strain. So per strain lah, per strain is 6 times 10 to the power negative 5 times the area. Is that okay? So, or you just put strain lah. F over A divide strain. So here, yeah, so A, get the A first. The A that I got was 2.267 times 10 to the power negative 6, yeah, meter square. So radius, you know, wire is a circular surface area, so it is pi r square. So therefore R is equal to A over pi, you square root it. So therefore A is 2.267 times 10 to the power negative 6 over pi, square root it, and you get C is the answer. Got it? Yeah.
Can.
I clear that first. Is that okay? Don't worry, all the solution will be provided after this. Yeah? Okay, then make sure that you just understand the concept first. Yeah? 20, an unstretched rubber cord is stretched by a force. So the force is plotted against extension X. F is slowly increased from 0, causing the cord to extend along path P. F is then reduced back to 0 along path Q. What is represented by the shaded area? Shaded area. I'm going to get you more on that, yeah?
Is it C?
Okay. What about Adam? Not sure, is it? Or
I'm not sure, but
okay, never mind.
put
Yeah,
on
I need to get you on this, yeah? So first one, yeah. The energy stored in the rubber band is called elastic potential energy. So elastic potential energy is this area. Area under the curve P. That is elastic energy stored in the rubber cord. Okay, that is A. B, the energy that causes plastic deformation. When you look at the graph, when you stretch until this point, look at the extension. Is there any extension? There is no extension. So therefore, plastic deformation never occur here. You get it? Yeah? D, the work done to extend the rubber cord. Yeah? Is also this one. The work done to extend the rubber cord is equal to the elastic potential energy stored in the rubber cord. Yeah, which is area under curve P. Now, I erase that. What about area under curve Q? Area under curve Q is the energy or the work done by the particle, yeah, to restore to original dimension, because you deform it. So therefore, it has to be restored back to the original dimension. So you stretch it and then you let go, it will try to restore. That is the work done by the particle. Work done by you is area under the curve P. Area under curve Q is the work done by the particle in the rubber cord. So therefore, yeah, the difference between the work done by you and the work done by the rubber cord, yeah, particles of the rubber cord, is dissipated as heat or thermal energy. Yeah, because sometimes sliding of the particle occur when you stretch it. Yeah, friction occur as well. So therefore, the answer is donkey. Hey, sorry, the answer is C. Yeah, C. Okay, Adam? Okay. Number 21. A guitar string vibrates to create a sound. Speed of the wave in the guitar string is always 440 meter per second. Vibrating string creates a sound wave that moves in the air with a speed of 330 meter per second. So which graph shows the variation of frequency with the wavelength? Adam says C. What about Jamie? Adam give the explanation, which is very good. Yeah? If can, give me as many explanation as possible. Jamie agree with the answer from Adam?
I think so.
Okay, so first of all, you know that speeds are different. Can you see that? Can you see this is frequency against wavelength? V equal to F lambda. So F is inversely proportional to lambda. So the graph cannot be A or B. So it's either C or D. So look at the string and the guitar. So the guitar string is 440. So the speed is higher. So when the speed is higher, it is more curvy. Yeah, so and then the speed of the sound wave is lesser, so it's less curved like that. It's more straight lah. So therefore, yes, the answer is C. Yeah. Then okay, the next one here, wave. Yeah. The graph shows the variation with time of displacement for two different waves x and y. Wave x has a frequency f and an amplitude a. What is the frequency and what is the amplitude of wave y?
B.
B, is it? Congratulations. Yeah, correct. B is the correct answer. What about this? A loudspeaker emits a sound wave into a tube, initially full of water. Tap at the bottom of the tube is open so that water can slowly leave the tube. For some lengths of the air column in the tube, the sound heard is much, much louder. So the first loud sound, this is stationary wave, yeah? Is heard when the air column in the tube has a length x. The next time the loud sound is heard is when the air column in the tube has length y. What is the wavelength of the sound wave from the loudspeaker?
C.
C, yeah? Okay. What about Adam? So I'll just look at the methods of how Adam get the answer. Okay.
Can you explain this question?
Sorry?
Can you explain this question?
Okay, I can explain this question, no worries. So this is tube close at one end. Why I say this is tube closed at one end? Because the tap, you turn it, yeah, you tighten it so the water cannot flow out. So therefore, initially x, okay, this is 1 over 4 lambda. I do agree, 1 over 4 lambda is equal to x. And they say the next time, the second wave is heard is when, so you know the open end has to be anti-node, the closed end has to be node, right? So the next time is like this. Yeah. So this is 1 over 2 lambda plus 1 over 4 lambda. So the next time is 1 over 2 lambda plus 1 over 4 lambda is equal to y, which is 3 over 4 lambda, which is equal to y. Can you see that? So first equation and second equation. Yeah, I use the second equation minus the first equation because I want to get positive one. So 4 over 3 minus 1 over 4 is equal to 1 over 2. Yeah, because 2 over 4 is equal to y minus x. So therefore lambda is 2 times y minus x. So therefore the answer is C. Okay? Yeah? Okay. Clear that? And then, okay, this is Doppler effect. Equation is given, so I'll be giving you the equation.
A.
The answer is A. Good job. Both of you, very good job. Okay. Now, 25. The graph shows how the intensity of the electromagnetic radiation emitted from a distant star varies with wavelength. So in which region the electromagnetic spectrum is the radiation greatest intensity? So this one. Greatest intensity, I want this range. Oh, Adam used the speed of light divided by the wavelength, is it? It's roughly about 150 times 10 to the power negative 9. I didn't memorize the wavelength, so I have to do in terms of frequency. Yeah? Mm. Mm.
Is visible light.
Um, Jamie said visible light. What about Adam? Visible light, yeah, Jamie. Yeah, first thing that maybe some hint here lah. Visible light, you just memorize the two wavelength here. One is the blue one, the other one is the red one. Red is 600 to 800 nanometer. Blue is about 300 to 400. So this is away from visible light. So what is before visible light? Ultraviolet. Yeah, Jamie? Yeah, is that okay? So you just memorize blue and red. Yeah, because blue is the lowest one and then red is the highest wavelength. Yeah? So therefore the correct answer is C lah, ultraviolet. And what about 26 here? The statement concerning a stationary wave is correct. Which one is correct? And if you choose that answer, give me why the others are wrong. Give me and then try to correct that.
A.
Okay, why B, C, and D are wrong if you choose A. Okay, I would like to see the answer for Adam first before I answer that.
B is supposed to be maximum displacement.
B supposed to be displacement, is it?
Maximum displacement.
Okay, amplitude of the stationary wave is equal to the amplitude of one wave. So bear in mind, yeah, Jamie, for stationary wave, you cannot use displacement. There is no displacement. All are amplitudes. Yeah, all the particles are in terms of their individual amplitudes. So the term displacement is not usable in stationary wave. Yeah. So instead of saying that amplitude of a stationary wave is equal to amplitude of one of the waves creating it, no, this is actually equal to the two waves creating it. See, the wavelength of the stationary wave is equal to the separation between two adjacent nodes. Okay, let's say. So this is 102 lambda is not equal to lambda. So therefore, this is wrong. Yeah? Let us look at D. There's no displacement of a particle at antinode. Hey, antinode, Adam. Antinode is here. Maximum. Yeah? Maximum amplitude. So of course, there is displacement. So yeah, A, all the particles between two adjacent nodes oscillate in phase. Okay, I do. Note, yeah. One, okay. Look at this carefully. This is node between two adjacent nodes, yeah. Can you see that if I want to depend on this, yeah, black line wave here, the line, yeah, not the dotted line. So how to form this wave profile? All the particles must oscillate downwards. Can you see that? So here, all the particles must oscillate upwards. So you see that between two nodes, they are adjacent. Can you see all the particles are oscillating downwards? That means, yes, it is in phase. Yeah, in stationary wave, there's no way to get phase different. Yeah, it is either in phase or out of phase. All the particles between, yeah, two loops are oscillating out of phase by 180 degrees. So therefore, the answer is A. Yeah, Adam? Okay, what about number 27 then? Which waves could best demonstrate diffraction through a doorway? Best diffraction is when the gap is similar to the wavelength. Jamie has the same answer as well.
I don't know, miss.
The answer is yes, sound wave. Because ultraviolet, yeah, visible light, X-ray, their wavelength is a lot smaller. Yeah, as compared to the sound wave. Okay? Okay. What about number 28? Two loudspeakers. Okay, this is interference. A microphone connected to an oscilloscope is moved along a line some distance away from the loudspeakers as shown. So, which statement about the waves emitted by the loudspeakers is not a necessary condition for the microphone to be detected?
B.
Along the line where there is no sound. No sound, that means destructive interference is not a necessary. Yeah.
B.
D, is it? Okay, first of all, I'll look at Adam's, since Jamie said D, the wave must have the same wavelength. It doesn't mean that, okay? Same wavelength, it doesn't matter, it doesn't matter. Yeah, the wave could have, yeah, any wavelength. Yeah, as long as they meet at a point. One crest must meet with one trough. That's all that we want. Yeah, even this one has a 13 wavelength. This one has a 12 wavelength. Yeah, it doesn't matter. Or 12.5 wavelength. Of course, destructive interference occur when, yeah, path different. Why you have this path different? Is because of the different wavelength, Jamie. Yeah, so therefore, not necessary. This one is, yeah, which statement is not a necessary condition? Yeah, wait, is not. Which statement about waves emitted by the loudspeaker is not necessary? That means, yeah, it is. That means this must be the same wavelength. Wait, it's not necessary condition for the microphone to detect. If the wave have same wavelength, wait, your answer is D, yeah. Hold on, I look at other answers first. The wave must have the same frequency. Okay, same frequency. same frequency, so that they can, if they have same frequency, same wavelength, that means they travel with the same speed. Okay, wave must be emitted with a similar amplitude. Similar amplitude. Is it not necessary, Adam? Because if they are not similar amplitude, yeah, how do you detect no sound? Crest, yeah, must meet trough exactly. If one is crest is A, but the trough is 0.5 A, can you see that you still detect sound? I want no sound. So therefore, it is necessary to have same, yeah, amplitude. You get it, Adam? They must be similar amplitude so that I can detect no sound, destructive, 100% destructive interference. So now I'm looking at it, no sound, yeah. So therefore B cannot be the answer. If the wave have the same frequency, this is loudspeaker. Don't you think that the sound, yeah, the wave is a sound wave. The sound wave travel with the speed, constant speed, what? So therefore, to travel with the constant speed, v equal to f lambda. Don't you think the frequency must be the same? The lambda must be the same because this is sound, not light. Light, we have EM light. We have we have microwave transverse. This is longitudinal wave. Longitudinal wave only subjected to sound, right? So don't you think they must have the same frequency? Yeah, if they have the same frequency, they must have the same wavelength, so that the speed must be the same. Yeah, I say why A is not necessary, because when you say that, yeah, what is necessary here is that I must make sure that these two loudspeakers are coherent source. What is coherent? What is the definition of coherent? Coherent means no phase different. Yeah, if no phase different, meaning to say that they are in phase, or constant phase different. They can have phase different, but yeah, the phase difference must be constant. So therefore, it is not necessary for the two waves to be in phase. They could have phase different, but yeah, must be constant phase different, so that the two sources are coherent. You get it? You get it? So therefore, it is not necessary to be in phase. Therefore, the answer is A. Yeah? I will do further explain in the solution later. But if you have any hesitation or anything that you want to question here, feel free to do so, because this is discussion. Yeah. So number 29, yeah, calculation. So the parallel beam of white light passes through a diffraction grating. Orange light of wavelength 600 nanometer in the fourth order diffraction maximum coincides with blue light in the fifth order diffraction maximum. What is the wavelength of the blue light? Show me the equation.
B, please.
B, yeah? Very good. Okay, fine. I will lock B. So therefore, the answer is B, correct. B is correct answer. And what about number 30? On which electron is the direction of force on the electron? Okay, yeah.
This one I don't know.
This one you don't know, is it? Okay, Jamie, yeah. You know electron will be attracted to the positive, yeah, positive charge. So therefore, eliminate D, yeah, eliminate B, because it is getting away from positive. And because it is a curved line, because electric fields are curved, can you see curved line here? So if you want to find the direction of the force on the electron which is attracted to the positive charge here, you have to draw tangent. If I want to find, oh, what is the force acting on the electron at this point here, so I have to draw tangent. Can you see that? C is not drawing the tangent. C is like attracted straight away to the positive charge, which is not true lah. Yeah, is that okay? So if it is a curved line, to find the force, draw tangent to that point. So therefore, the most appropriate answer is A.
So
Yeah,
means you need to know the direction of force, you need to draw a tangent.
tangent. Yeah, because the direction of the force of the electron is towards positive what? Positive charge. Electron will be attracted to positive charge. But yeah, in which the force direction, it must be tangent to that curve point. Yeah? Okay, Jamie? Okay, what about 31? Oil drop. What is the charge to mass of the oil ratio? Okay, Adam, I'm waiting for your solution as well. Jamie, if you get the answer, let me know.
Yeah, miss same answer.
Same answer, yeah? So that means I don't have to do the solution, yeah? Okay, good, okay. Adam, okay, don't do the solution, yeah? Okay, so clear that. Okay, number 32. Oh, 32, I think the equation will be given. Hold on, yeah? Let me copy the equation that is given here. Um, yeah, and then maybe if you want to find, okay, E is, yeah, the charge of the electron is given as well. Jamie got the answer, just let me know, yeah? Wow, such a big number there.
You means I got A.
Sorry?
Got A.
You get A, huh? Just like Adam. I'm looking at Adam's solution, yeah, and Q. So oh, he replaced that. Good, good, good. So therefore, average drift velocity for, okay, good. What about number 33? What is the definition of potential difference? Jamie got the answer?
It's D.
Do you get the answer? Is it B as well?
D.
Donkey, yeah? So potential difference is defined as work done per unit charge, yeah? To move the charge from one point to another point. Yeah, Adam? This is a product of current and resistance, yeah? IR is not the definition of the potential difference. It is because potential difference is directly proportional to the current. So when you plot the graph, you get this V I, then, yeah, from the ratio of the graph gives you resistance. Yeah, product of electric field strength and distance is also not potential difference. It is another way to express potential difference. Power, yeah, per unit current is also not potential difference. Definition, only one definition. Okay, so okay, can we try maybe one more, please? Okay, so what about this one? A cable. What is the length of the cable?
Can you explain this question?
Wait, yeah, I haven't done with this question actually. Hold on. Okay, let me explain this question, yeah? Or, yeah, Adam, you haven't done with this question, is it? Haven't done with this?
Leave it
Yeah.
blank.
Oh, you leave it blank. Okay, wait, yeah? Wait, okay, let me do that first. Uh, I'll, wait, yeah, what am I finding, yeah? Wait, okay. You can do that while waiting for me, yeah? Okay.
Miss.
Yes? You get the answer?
No, the L, is it the two line or only one line?
Two lines. The L that you count, the L that they want is only one line.
Oh, okay.
So I explain, yeah, this question. This question, they say this is a cable. This is the length of the cable L. Consists of two wires. So that means L, this is also L lah. Two wires, ma. Connected to 12 volt power supply. Negligible internal resistance. So this is the EMF lah, power supply. Yeah, but no internal resistance. So when the potential difference across the lamp, what I use voltmeter to measure, yeah, I get 10.5 volt. Yeah, that means some of the voltage has been used out, yeah, to drive the electrons through the wire. Yeah, so the current in the wire is 2.50 ampere. Each wire is made of metal of resistivity 1.7 times 10 to the power of 8, negative 8, yeah. Cross sectional area of 6 times 10 to the power negative 7. What is the length of the cable? So first of all, when they give you resistivity, straight away you must know that R is equal to rho L over A. So but the problem is they ask you to find the length. This is length lah, but you don't have R. So what is the length that you're supposed to find? The length of the cable. So therefore this R must be R of the cable. You get it? So this is the R across the, this is the voltage or the potential difference across the lamp. This is the EMF. So therefore the potential difference across the wire is 12 minus 10.5 volt. Yeah, 12 minus 10.5, that gives you 1.5 volt. 1.5 volt is the potential difference across the wires. Yeah, so I want to find the resistance across the cable. So R is equal to V over I, 2.5. Is that okay? So 1.5 divide 2.5, 1.5 divide 2.5, and I get 0.6 here. Yeah, so this is 0.6. Rho is 1.7 times 10 to the power negative 8. L is L. This is actually double L, yeah, because you have two L. So I put L as small l. Over area is given 6 times 10 to the power negative 7. Can you see when you get your L, you have to divide 2 because this is the total L. Yeah? L means L plus L, 2L. So yes, the answer is 10.6. Is that okay? So number 35, I believe that both of you have done, yeah, to question number 40. So let us have some discussions here. Let us finish that 5 more questions here before we start with uniform circular motion, which is A2 topic, yeah, first topic of A2. So number 35 here, in the circuits shown, the power supply has an electromotive force, EMF, greater than the normal operating voltage of the lamp. The internal resistance of the power supply is negligible. The resistance of the variable resistor is adjusted from 0 to the maximum value. In which circuit could the voltage across the lamp change, yeah, keyword, change from 0 to its normal operating voltage and not exceed its normal operating voltage? Because now the EMF given, yeah, is greater than the normal operating voltage of the lamp. So you could burn the lamp. Yeah, so let's say EMF is 12 volt, but the lamp only needs 6 volt. So therefore, you need to do some modification so that the lamp is not being burned, so that the fuse in the lamp is not being melted. So which is your answer? I still want the voltage across the lamp to change. I want to change the voltage across the lamp. But at the same time, I don't want the lamp, yeah, to act the EMF that, okay, pass through the lamp, the PD across the lamp cannot exceed its normal operating voltage. Yeah, Adam say A. What about Jamie?
I think also A.
Okay, if you say A, if you put this, yeah, variable resistor across here, yeah, variable resistor can only change, yeah, can only, what if you see, yeah, variable resistors from 0, that means if from 0 ohm, right, 0 ohm, as if there is no resistance, you know. So if this resistor is connected in parallel to the lamp, the resistance across the lamp is even lower. So a lot of current will pass through the lamp and burn it. You get what I'm trying to say? Because the variable resistor is adjusted from 0. That is the keyword. If you adjust from 0 as if, yeah, start from 0, that means as if there is no variable resistor. There's no resistor in front of it to block the excess current. EMF larger means a lot of voltage. A lot of voltage meaning to say that current is very large, depending on the resistance here. So resistance is very low here because even if you connect in parallel, you will make the total resistance even lower. So yeah, so current will be larger. A lot of current will pass through the lamp and the lamp could burn. So therefore, I cannot accept A. Yeah? A is not the answer. Yeah, I also cannot accept C, as if you start from 0 ohm. Oh, of course, the EMF, yeah, which is 12 volt, let's say it's 12 volt. This one only needs 6 volt. Yeah, this circuit is definitely, yeah, is going to burn. The lamp is going to burn. Yeah, so what about this? You start from 0 ohm. You start from 0 ohm, so 12 volt, all the 12 volt will just pass through the 6 volt lamp and you burn it as well. But look at B. So you have resistor here to already block, yeah, some amount of the current. So if, let's say, yeah, I start from 0 ohm, it doesn't matter because I have this protecting resistor to protect the bulb. Yeah, because if you start from 0, that means this resistor and this resistance of the lamp are connected in series. They are connected in series. Let's say this is depending on how many ohm of the resistor you want to put there. It's a fixed resistance. So therefore, there will be a blockage of the current. Yeah, and some more, this bulb is, yeah, in series with this resistor if this variable resistor is 0 ohm. So therefore, resistance is very large. Total resistance is very large. So you could save the lamp from being burned. So the best, yeah, answer is B. Get it? Okay? And then, okay, if you don't understand, stop me at any point, yeah? Number 36. Three identical lamps, L1, L2, and L3, are connected to a battery with negligible internal resistance, as shown. What happens to the brightness of the lamps, L1 and L2, when the switch S is closed? Yeah, what happens when the switch S is closed? So this one talk about the series and parallel as well, yeah, concept. So what do you think? Whenever you have the answer, do let me know. Okay? So what do you think about this? Lamp 1 and lamp 2. Mhm. Jamie got the answer?
B.
Or oh, Jamie got the answer. Very good. What about Adam? Reason for you choosing B? Because I really need to know the reason. Yeah? There must be a reason why the answer is B. Why your answer is B? Mhm. Any specific reasons to that?
Hard to explain.
Don't know how to explain. Adam, do you have the answer?
I'm not sure if it's A or B.
Okay, so it is A or B. Okay, let me explain this. When the switch S is being closed, that means this circuit is a closed circuit. Yeah, so the EMF of the power supply, let's say the voltage of the power supply is not changed. Let's say 6 volt, then it's 6 volt. So but can you see that? Okay, 6 volt, it will produce, yeah, it will provide a certain amount of current, which is, yeah, let's say 2 ampere, for example. Yeah, so the whole 2 ampere will pass through lamp 1, which is L1. But hey, because at switch S is being closed, therefore it will create a junction here. So these 2 ampere will split out. When they say, are these 3 lamps identical? They identical, yeah. Keywords identical. Can you see that? These 2 ampere will split out to 1 ampere and 1 ampere each. Why? Because these 3 lamps are identical. And lamp 1, it does not affect because lamp 1 got the current from the power supply. There is no splitting. Yeah. There is no division of the connecting wires there. So the whole 2 ampere will just pass through L1. But here is the junction. Junction is where a current will split. But since L2 and L3 are identical lamps, so therefore this current will split to 2 equal values here. So 1 ampere pass through L2, 1 ampere will pass through L3. So the L1 will get brighter. Lamp 2, yeah, since only lesser current pass through L2, so L2 will become, as compared to L1, yeah, you see 1 ampere pass through L2. L1, yeah, there is 2 ampere that's passing through L1. So therefore, yeah, L2 is dimmer. Yeah, so therefore, yes, the answer is B. Okay, any questions? Stop me at any moment. So number 37, in the circuit shown, the 6 volt battery has negligible internal resistance. Resistors R1 and R2 are, and the voltmeter each have a resistance of 100 kilo ohm. What is the current in the resistor R2? If you have the working, Adam, feel please to draw on the screen. Feel please to show me your working, yeah? I want to find the resistance of R2. And let me know how do you get the answer. Yeah, Adam choose C, yeah? Let me know how do you get the answer.
Same, miss.
Yeah,
Same.
yeah. How do you get the answer, I wonder? I am using, yeah, V equals to IR. I'm using Ohm's law. So therefore, V is a total, VI must be total, IR must be total R. So therefore, my I total is equal to V total over R total, yeah? V total is 6 volt, yeah? R total, yeah? These two are in parallel. So I have to redraw the circuit to this circuit, yeah. Okay, then okay, this is 100 kilo ohm, this is R1, and then R2 and okay, parallel. So I'll find my 1 over R total, yeah, for this circuit here. 1 over 100 plus 1 over 100, then you okay, R total will be equal to, you just invert lah, yeah, it will be 50 lah, kilo ohm. So therefore here, yeah, the R here will be 50 kilo ohm. I redraw the circuit, so it will become like that. So therefore, I take R total is 150. Kilo is 10 to the power of 3, yeah. So therefore, yeah, I have 4 times 10 to the power of negative 5 ampere as my total current. That means the current that is flowing out from 6-volt battery is 4 times 10 to the power of negative 5. Yeah, then okay, of course 4 times 10 to the power negative 5 passing through here. But hey, look at this, this is a junction, guys. This is a junction where the current split. So split to how much? Yeah, split to this is 100 kilo ohm, this is another 100 kilo ohm, and they are arranged in parallel. So therefore it will split to 2 equal, yeah, values. So this is 20 this one will split to 2 times 10 to the power negative 5. This one will split to 2 times 10 to the power negative 5 because this is a junction where the current splits. So therefore the answer should be A. Resistor, current in the resistor R2, not the total current. Yeah? So therefore the answer is A. Is that clear? Yeah? Okay, yeah? And then number 38, which statement about two nuclei that are isotopes of the same element is correct? What do you think? Isotopes. What is isotopes? Isotopes means, yeah, nuclei that have the same proton number but different nucleon number or different neutron number. Is that okay? So which statement about two nuclei that are there are isotopes of the same element is correct? Let us look at A. The nuclei each have the same acceleration when in the same uniform electric field. Is that correct? Same acceleration. So nucleon number represents, yeah, means how heavy the nucleus is. If they are having different nucleon number, the heavier one, yeah, the acceleration of the lighter nucleus will be different from the acceleration of the heavier nucleus. So therefore, they cannot have the same acceleration. Yeah, they can have the same deflection towards, yeah, the same plate, but they could not have the same acceleration because F equals ma. Different forces acting on different masses to give you different acceleration. Okay. B, the nuclei each have the same number of neutrons. That's definitely not true. Yeah, the nuclei each have the same number of neutrons. That's totally not true as well. Uncharged atoms containing the nuclei each have the same number of electrons. Yes, it is true. Uncharged atoms mean neutral atom. Yes, so therefore the answer is D. Good job. Yeah, and then question number 39. In a nuclear physics experiment, a nucleus of 32S collides with a nucleus of 94MO. The nuclei combine together and immediately emit a single alpha particle. The nuclear reaction is shown. So what is nucleus at? What is nucleus at? It wouldn't be that hard, right? For this question here. So what is your answer? Wow, that's very fast, Adam. That's very fast. Okay, let us look at the nucleon number first. So the left hand side, okay, nucleon number, add up to give you, okay, 32 plus 94, gives you 126. Okay, 126. And you know alpha particle is 42He, right? So this is left hand side. Yeah, must be equal to right hand side. So right hand side, yeah, 126 is equal to, yeah, maybe I just put A plus 4. So A is 126 minus 4, which is 122. Yeah, the answer is quite obvious, is A. So let us check, yeah? So on the left hand side, 16 plus 42, this is proton number, yeah, which give us 58. So 58 is equal to Z, yeah, plus 2. So Z is 58 minus 2, which gives you 56. Quite obvious, so therefore the answer is A. Okay, good job. Which diagram represents the quark composition of an anti-neutron? So you need to know what is the quarks, okay, of neutron first. Neutron is made up of 3 quarks, okay, which are down, down, up. So since they want anti-neutron, so anti to all the quarks. Bar, bar, bar. So bar U, bar 2D. So therefore the answer is A. Is that fine? Okay, so we are done with our discussion on paper 1, October, November 2020, paper 1-1.